So in the last class, we treated conditionals and flow control. It was just about how to make our code make decisions on its own. So we can write a piece of code that if a certain condition is true, it should do something. If the condition is false, it should do another thing. It's just like you as a human being now. You woke up this morning, you know you had an online class. So since that condition is true, if I have an online class, it's true. Put on your laptop. If you don't have data, subscribe, sit down and start listening to the class. But if you did not have an online class this morning, I'm guessing there are other things you could have done. Part of that thing would be continue sleeping or remain in bed. Don't, or go eat something, or go jog, or go buy something. Okay, so as humans, every day we make decisions. Every day you make decisions. So you can also write your code or write your program in such a way that it will make decision on its own. For example, now you try registering on some sites and they will ask you to put your country. And maybe you put your country, they will say, sorry, our services is not available to this country. What do you think is the owner of the company that are making that decision at that point? Yes, they were the one that made the decision, but they made this when they were writing the code, that anybody that is not from this particular country that is trying to connect, let the person know that the person cannot connect. So that is what conditionals and flow control in our code means, and we covered it in the last class. And I also did give an assignment. So for those of you that did not do your first assignment, your assignment now is already 2. And please, I know everyone here is probably matured, so there is no need beating around the bush about doing your assignment or not doing it. The thing is this: if you do your assignment, it would expose your own weakness to you. Okay, it would, you doing your assignment will make you know, okay, if like say I've not gotten to where I'm supposed to be in this class, which means you know you need to pay more attention, make more research. But if you continue skipping the assignments, you will think you are following the class and you are learning, and you are not learning at the end of the day. Okay, the way for you to test yourself if you've actually been learning anything from this class is doing the assignment and seeing what you score from the assignment. Okay, so I am begging you again, you have another grace again starting from today till the next class. I understand we are working, I understand it's stressful. Lagos is stressful. I understand that. As I'm speaking to you right now, I'm not feeling good myself. I've been on meds for more than 4 days. Why? Lagos stress. So I understand the stress, but once in a while you need to just make sacrifices to get what you want. Okay, I did not become this good, or I did not get to where I am today by just watching classes alone. I got there by watching and practicing. Okay, attending classes is one thing, practicing is another thing. There is no level of smartness you want to say you are smart and all you do is just listening to a coding class without practicing. No be charm, you know, go sabi am. Because it is when you are actually practicing that you know, okay, this is just like you watching people driving car. I automatically assume you know how to drive a car. If you get into the car, you will know that watching and actually doing is a different thing. But when you watch and you do, boom, you get the best of it. Okay, and the good thing about it is, don't worry, a time will come and when you will get to a level where watching will be enough for you and then you can do. But that is when you have grown. For example, now there are some tutorials I watch online. I might watch them today, and when I'm building my next project, without practicing, I will apply it and it will work. But don't forget that the application is based on the fact that I already know some of the things they talked about. But for you as a beginner, for now, there are levels that you have to, there are things you just have to do. Okay, they are just those sacrifices you have to make. And one of the sacrifices is take time, read up, watch the tutorial and practice it. Don't just watch and let it go. And okay, the strategy I use when I'm watching a material is this. Now, I know some of these materials are really long because they are live classes. They are not short. Left to me, I prefer shorter tutorials. Okay, like 5 minutes, 10 minutes videos on topics that are broken down. but this our own are long one. But don't worry about that. I'm currently working on my online Python class. Maybe if it's ready, for those of you that attended this class, I can give you some form of arrangement, but that will be till then. But for now, since these classes are long, this is what you can do. Okay, if you sit today and you say, okay, you want to start with the lesson 1 and 2 video, watch 30 minutes of it. Okay, don't watch the whole 2 hours, 3 hours. You'll be worn out. That is, you will be worn out. There is no tactics to that. You will be worn out. Why? Because you see, as big as the brain is, and they keep telling us we are only using how many percent? Say, if only God, is it 1% or is it 10% of the brain? As big as the capacity of the brain is, when you process too many informations at once that you don't have an idea of before, it will get to a point and it starts being overwhelming. You can't really wrap your head around it again. And that's why, if you notice that most of our classes have not gone beyond 3 hours, and that's the truth. Forget it. If you sit down as an adult for more than 3 hours, forget the remaining hours. Are the information you will retain for the remaining hours is going to be limited, mostly if it's an online learning. If it's a physical learning now, it's kind of different, because at least we're interacting, we are seeing each other, we can take interactive breaks, and we get how it goes. But when it comes to an online learning, when you try to process too many information over a long period of time, it gets to a point your brain will stop. Your brain will still be retaining the information, but you can't really process it to understand it anymore. So this is what I recommend. Take all these classes. If there's anyone you've missed that you've not learned on, once you download it on your phone, do you guys know how to download a YouTube video? Anybody knows that yet?
Sure.
Okay, just one person. Okay, why I'm saying that is this. I know that having data every time to go online to watch a video can be stressful. Forget it. Me, I download YouTube videos sometimes. Maybe after this, I'll drop an app on the WhatsApp group that I use to download these videos. Although downloading videos isn't really recommended because it doesn't give the content, the creator of the video, views on YouTube. But this one, I'm giving permission to download. Okay, once you get the app, all the link to this video, all you need to do is copy it, paste it in the app. It will show you the video. Download it on your phone. Okay, once you have the video on your phone, all you need to do is this. Start with, if you download 2, depending on how many classes you have missed, download the videos for all of those classes. Once you are done downloading, all you need to do is this. Just the first video you downloaded, set the first 30 minutes. Okay, I'm going to watch this first 30 minutes. Watch the first 30 minutes. Practice what is done there. But don't watch and practice at the same time unless you are familiar a bit with Python. If you're not familiar with what was done in that 30 minutes, sit down first, don't code. Watch it as if you're watching a movie. When you are done with the first 30 minutes, the next thing you are now supposed to do is this. Hello, can you guys still hear me? Hello, are you guys still with me? Are you still with me? All right, good. So once you're done with the all right.
I can hear you.
Okay. Once you're done with the first 30 minutes, you can now practice what was done in that 30 minutes. Once you know you are good, you are done with that, move to the next 30 minutes. Before you know, once you join 30 minutes, 30 minutes, 30 minutes, 30 minutes, you are done with the whole 3 hours video. And you have mastered it. And what is good about that is you can easily know where you stopped and where you continued in the video. So if today now it was the first 30 minutes you watched, tomorrow if you want to resume it, you know that you are starting from 30 minutes to the next 30 minutes. Just watch it in sections, small. Don't cramp everything off it and let it go that way. Okay, so just try to do that, and please, I am begging you guys, try to watch these videos if you've not. For those of you that have attended the class throughout, you might not really need to go back to watch it, because at least the class, you witnessed the class. But if you did miss a class, please go watch the video. All right, Now, with that being said, for the assignments too, we've talked about that. I will not go back to that again. Try to just do the assignments. Okay, so thank you guys for that. Let's start the class. Just give me a minute, let me take something here. Okay, so today there was a topic I purposely left out of the last week topic, and that was because I want everyone to be present before we do it. And this is the topic here: loops, for loops, and while loop in Python. Now, although all topics are important, okay, but there are some of those topics that if you miss, it will be very, very difficult to pick up on it. So we'll be looking at it first before we move to our lesson 6. Okay, so loops in Python. Let's go ahead and start up our program. Okay. I think it should be Python. You said what?
Should we create another file for you?
No. You can use the project. You know you have a project folder you have been using, right? Just go ahead and still use that project folder.
Okay.
All right. So I'll give you guys just a minute or two to open up your projects. Let me know when you are all done, please. Okay, I guess we're all done opening our code now. So good. Please, I'll be giving you time interval at different intervals to write the code I have written too, because I want all of us to be in sync. For those of you that missed the last class, this was the game we started making in the last class. Okay, it's a simple guessing game in Python. If you remember all those our childish game we used to play, I am something, I kiss my mother before I die, they'll say it's a matches, or they'll say I am something, I put on a red cap, what is it, can do, and so on and so forth. So we tried replicating it in Python. Maybe are you with us? You have not heard your voice since you joined. Hello.
Hello.
All right. Good morning.
Yeah.
All right. Okay, and I know Samuel is at work, so he might not be able to speak up, but I am sure he's with us.
Yeah, yes, it's good.
Okay, good. Okay.
Sorry, can we download the recording?
Yes, you can. I'll drop an app on the WhatsApp group today, and I'll drop description on how to use the app to download YouTube videos. You know, I'm hosting your videos on YouTube, although it's not public, but once I give you the link, you can copy the link, paste it on that app, and download it.
There's no YouTube video.
You said?
The videos are not YouTube.
The videos
They're not on YouTube.
If you go to my YouTube channel, you will see it because I did not list them as public videos.
Okay.
But once I drop the link to you, you will have access to it. All right, so this was the guessing game we did, and we did this using the if and else we did in the last class. Okay, so it was a simple game. Once the game starts, let's see how it works. If I execute this game now, okay, it says we should enter the answer to the riddle. What's the riddle? Question says I am something, I always wear red cap. The answer is candle. So if I go ahead and put something else, let's say rat, it says oops, you are wrong, the end. We run the program to play again. If we run it again, I am something, I always wear a red cap. If I put the correct answer, candle, you see it says you are correct, the end. We run the program to play again. So this was the basic game we built in the last class, and what I said is throughout the process of this class we'll be improving on this game, because right now you can only play the game once and it ends. But we don't but we don't want it to always be like this. Okay, we want it to have a kind of situation whereby if the user is done answering the question, okay, we'll ask the user, do you want to play again? If they say yes, we'll let them play again. If they say no, we end the program. Okay, and we can even get to a part where we will not just have one question, we'll make it look like a quiz. Okay, once the user answer one question, we give them a score. Another question comes up, they answer it again, another question comes up, so we can give them more than one question. As they answer the questions, if they score the answer correct, we give them a mark. At the end of the game, we'll tell them your score was this. So you see how that's how we'll be improving the game over time. Okay, that's how we'll be improving the game over time. So I would beg you, please, I know work is stressful, try as much as possible not to miss most of these classes, and if you do for some reason, watch the videos. All right, so today we'll be quickly looking at loops. Let me create a new file. I'll call it loops.py. loops.py. All right, so that's loops.py. All right, so with that created now, what is a loop? Now I know the word, if you look at it, even in the English definition, would already give an opinion to what it is. A loop is basically an event or an occurrence that keeps repeating itself. Okay, you know, when somebody tells you, I'm sorry, I'll change. Tomorrow you say, I'm sorry, I'll change. Next tomorrow, I'm sorry, I'll change. That person is basically in a loop now. Why? Because they are doing the same thing over and over and over and over and over again. So sometimes in your program, for those of us who did, maybe if you were a science student in school and you did physics, I'm sure you remember this thing we refer to as a simple pendulum. Or okay, let me not use physics so that you guys can relate. Let's take these children's, you go to a children's playground, they have this thing that they swing on, that swing that they will sit on, and then you push them and they go. Although not only children, me myself, I still like that thing. So so you push, waiting, I don't understand. So you push them, you push me, and I go back and forth. You see that if you study that occurrence well, you tend to discover that it's the same thing that is happening, but it's just happening over and over and over again. I go back, I go front, I go back, I go front, I go back. It's the same event, but it's happening over and over and over again. That is what we call a loop. Okay, that is what we call a loop. Another example can be you. Maybe when something happens, you're not okay with a situation, or you are in deep thoughts and you are just walking up and down your room, back and forth. You go towards the door, you come back again, you go towards the door, you come back. That is a loop. Okay, so in programming, okay, we might sometimes want to execute a piece of code more than one time. Are you following what I just said? You might want to execute a piece of code more than one time. Like you want it to repeat itself over and over and over and over and over and over and over again. That is a loop. So how do we do that in Python? That is what we want to look at. Take note of this. Programming, although I would not say it's not that easy, but at the same time, it's not that hard. What I do is whenever I'm learning a new concept in programming, I look for a way to relate it to something I do every day in the real life. Because if you can do that, it makes doing that particular thing easy now. Now that we have understood the real life scenario of a loop, let's see how we can apply it in Python. Now, if I come here and I type print, I want to print okay, let's just go with tech weight. If I come here and I print tech with Steven, now I want to be able to do this thing over and over again, or I want to print it 10 times. Now, with our current knowledge, what we'll do will be, we'll come here, we'll do Control V RB up to 10 times, and boom, we feel like we don't solve the problem. Now, this works, right? This works, But one thing you need to know about this is it's not efficient. Because if I tell you, okay, we'll do it 100 times, you want to do Ctrl V, Ctrl C 100 times. Now, if you do it up to 100 times, you'll be confused because you have to now count it if it's actually 100. It's not efficient. So how do we use loop to solve this? Now, in Python, there are two kinds of loop we have. Okay, we have one we refer to as the for loop. The for loop. And we have the other one we refer to as the while loop. And we'll be looking at the two of them today. So we have the for loop and we have the while loop. Now, I'm going to start with the while loop because it's easier to understand before we move to the for loop. Although the for loop is still easier to understand, but it will deal with some things I don't want us to get into yet. So let's start with the while loop. What is the while loop? Well, how the while loop runs is this. Don't forget that, imagine if you were thinking about something. Maybe your boss gives you a task now, and you were just cracking your brain as to how do I do this? And you were thinking, you were walking up and down in your room. The moment you find a way to do it, you would stop walking up and down, right?
So,
Exactly. Now, by stopping, you have ended that loop. Okay, by stopping, you have ended that loop. Why did you end the loop? Because the reason you were looping or the reason you were going up and down has been solved. Okay, the problem that you had that was making you go up and down has been solved. Just like when I am on a swing now and one of you pushes me and then I'm going up and down. Now, the moment the force you use to push the swing reduces, what happens to the swing over time? It stops. It gets to a point, it doesn't go too further, and like that, it comes to a halt. So now, what does that tell us about a loop? That tells us that a loop should also come to an end. If not, you will have this thing we call in programming as an infinite loop. An infinite loop is a loop that never ends. And the problem with a loop that never ends is it will crash your program. So when you are dealing with a loop, you need to put a condition in place that will make it end. So let's look at the while loop now. To write the while loop in Python, you just simply say while followed by a condition. I mean, this while is as if you are saying something. I'm guessing we know the meaning of why. Why is more like a condition, you know, right? You know that, right? When I tell, imagine I tell Mr. Victor that while you are at the market, please help me get something. In other words, what I've just told him is when you are in the market, get this thing, which means once he leaves the market, there is no need to get it anymore. So when you are using the while loop, you are supposed to follow it with the condition. So I can say something like, let's create a variable at the top here. Let's say number or num is equals to 10. Then I'll say while num, okay, is less than 10. You know, we talked about these conditional operators. I know we've talked about it before, but we talked about it extensively in the last class, which is why for those of you that missed the last class, going back to it is important. So I'll say while num is less than 10, colon. So a while loop also works like a function block. So it's supposed to have a block of code inside it, and you know, to indicate that a piece of code is under a block of code, we use this indentation. So I'll say while num is less than 10, I want to print, what do we want to print before? Tech with Steven, right? So I'll say while num is less than 10, print tech with Steven. What this is saying is this. It's telling Python that as long as this number is less than 10, keep printing tech with Steven. Did you see that? Now, okay, I made a mistake up here. We should not set num to 10. Let's set it to 1. Okay, let's set it to 1 because we want to print tech with Steven 10 times. Okay? So, I'm saying why num is less than 10, go ahead and print tech with Steven. Now, if I run this program, it will run. but I will enter into an infinite loop. Can anybody look at the code and tell me why I will enter into an infinite loop here?
Because now we always less than 10.
Exactly.
Says number.
Exactly. Samuel, maybe Mr. Victor, if you don't catch what he said there, this is what he said. He said that because norm will always be less than 10. Did you catch that there? Because if you look at it, norm is 1. And this condition is saying why norm is less than 10. Norm is 1. 1 will always be less than 10. What does that mean? Our program will keep printing tech with Steven for life. Because since the start of time till now, norm is always going to be less than 10. Let's see it in action. Let me go ahead and run this program. Did you see? Did you notice that this thing is still printing? If you watch the cursor,
it will face the system.
You see that it's still printing. It has printed more than 10. Let me be scrolling. I can't even scroll. My system is basically hanging right now. I can't even debug. I can't stop this here now. Why? Because I've just entered into an infinite loop. If you notice, let me try to scroll to the bottom. Did you notice as I came to the bottom, it went back up? Watch this thing here. Watch my mouse. You see I'm dragging that brown box to the bottom to scroll. But the moment I get to the bottom, it goes back up again. See it? See it? Back up again. This program right now is still running. It's printing tech with Steven. Now, why is this happening? Well, we already answered the question. Because norm will always be less than 10. So what we need to do now, we need to look for a way to make this condition become false. Because this condition, this piece of code will always run as long as this condition is true. So what we can do is after printing, after each loop, okay, after each successful iteration, okay, what is an iteration? Now, if we are printing Steven 10 times, okay, each print is what we refer to as an iteration. So you know that swing now that is going up and down when you push the string, and when you push it, each movement, that is when you push it, the moment it goes to the front and comes back, that is one iteration. If it goes again and come back, that is another iteration. If it goes again and come back, that is another iteration. Now all of these iteration all together, when they repeat themselves, is what we refer to as a loop. So now we are printing tech with Steven inside this loop, but the thing is entering into an infinite loop. So what can we do to fix this? Well, what I can do is this. I can come down here and say norm is equals to norm plus 1. Now, let me explain what this will do. Don't forget that a loop is a piece of code that we execute over and over and over again. Now, if we run this program now, once Python gets to y here, Python knows that yes, this is a loop, this is a loop, this is a loop. What do I do here now? Okay, Python will say, okay, y norm is less than 10. This is a loop. What does this person want me to do? This person wants me to print tech with Steven. Now, imagine we don't have this line here. Let me delete it. Now, you know, a loop, like I said, is a piece of code that will execute over and over again. So after Python is done printing tech with Steven, it will come back again to the condition because it is a loop. The condition says what? Y norm is less than 10. What is the current value of norm? Who can help us out? What's the current value of norm?
1.
Norm is 1. Good. Is 1 less than 10?
Yes.
Good. Because the answer is yes, Python will come here and print tech with Steven again. And then it will come back to the condition again. What is norm again? Norm is still 1. Is 1 less than 10? Yes. It will come here, print tech with Steven again. Come back to the condition again. What is the value of norm? 1. Is 1 less? You see why we entered an infinite loop? Because norm is always 1. So the condition would always be true. But the moment we put this line of code here now, once Python comes here, y norm is less than 10. What's the value of norm? 1. Is 1 less than 10? Yes. It will print tech with Steven. Once it's done with this, it will come to the next line. What are we doing in the next line? We are adding 1 to the former value of num. So instead of num being 1, num will become 2 now. So by the time Python comes back up here, num now is 2. Is 2 less than 10? Yes. It will print text with Steven. Add 1 again to num. Num will become 3. Come back up here. Is 3 less than 10? Yes. Python will print text with Steven. It will continue doing that until it gets to 9. Once it's done printing text with Steven, it will add 1 to num. Num now will become 10. It will come to the condition. Is 10 less than 10? Exactly. No. This condition now becomes false. So the loop will stop. So the loop will continue to run as long as the condition is true. Once that condition becomes false, it will stop running. So let's go ahead and execute this now, and you will see that we will not enter that infinite loop again. Did you see that our program stopped running? But
Yes.
But here is the catch. If you count how many times it printed text with Steven, it should be 9. Let's confirm. 1,
To be 9.
3, 4, 5, 6, 7, 8, 9. Who can tell us why it's 9 and not 10?
It will be 10 minus 1.
Exactly. Because 10 minus 1, what it means is this. The last time it was supposed to print the 10th one, the condition will say it's 10 less than 10. We know 10 is not less than 10. So it will not run again. If you want it to run the last time, you can use the condition of num less than or equal to 10. You know, in that condition now, 10 is not less than 10, but is equals to 10. Which means the only time it will stop now is when num becomes 11. So if we run this now, we should get it 10 times. Let me end this. Run it again. We should get this 10 times now. Let's count. And run. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. You see that? Now that we have learned this, let me show you a simple trick to print 1 to any number you want in Python. Let's say I told you to write a program to print 1 to 50. You know, before you would do print 1, print 2, print 3 until 50. But like I said, that is not efficient. With this loop that we are running, did you notice that every time this loop runs now, the value of 1 will change, right? You know, the first time it runs, 1 is 1. I mean, num is 1. So num is 1, it will run again, num becomes 2. So instead of printing text with Steven here, how about we print num? What do we think will happen? Let's see it in action. Execute. Did you see that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you see that? Which means if I want to print 1 to any number I want now, all I need to do is put the number here. So if I say num less than or equal to 100, what do you think this program will do now? It will print me 1 to 100. Did you see the good thing about this? Did we all catch this? Maybe on someone, if you do, wave your hand, please. And technocrats, if you do, wave your hand. Okay, good. All right. So that is that for while loop. Okay, that is that for while loop. Now, the while loop can actually do a lot of things. Okay, before we go to the for loop, how about this? Let's test ourselves with a question. Let me say, let's try to write a Python program that will print all even numbers from 1 to 20. Who can remind us what even numbers are? Well, if you forget, Google is there to you. Sometimes I forget it. But even numbers are those numbers that can be divided, that are divisible by 1 and 2, right? So 1 is an even number, 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even. All those numbers that can be divisible by 1, themselves and 2 are even numbers. So if you want to look at that well, what do you think? Now, before you write a program, if you are being told to write a program, for those of you that attended one of my free classes, those of you that knew me before this our class started, there was a free class I once organized where we talked about algorithms in programming. And believe me, as a data science student or as a data structure student, knowing algorithm or data structure, as a data analyst or a data science student, understanding data structure is very important. That is why after this class, okay, I would advise you to stick around, because after this your class, I'll be organizing some free classes where we'll be talking about some of those other things that you need to be good at as a Python developer. I'm talking data structure and algorithms mostly. Okay, now what is algorithm? An algorithm is just defined as a step-by-step instruction followed to solve a particular problem. Now, the good thing with algorithm is that you as a human being, you use algorithms every day, even if you don't know. If I tell you now, if you look at your activity as a person every day, for those of you that work Monday to Friday, if you look at your activity as a person, you will notice that there is a pattern between everything you do from Monday to Fridays. You wake up in the morning, you take your bath, you eat a light breakfast for those of us that eat before going to work. You go outside. If you have a car, you get into your car, you drive to work. Even if you want to take public bus, you know how you do it. If you look at your activities for Monday, you will notice the same pattern with your activities for Tuesday. You will notice the same pattern for your activities for Wednesday, up down till Friday. Am I right with that? So somehow you are following an algorithm, but you don't know. What is an algorithm? An algorithm is a step-by-step instruction followed to solve a particular problem. What problems do you have when you need to go to work? You have the problem of getting to work. How do you solve the problem? Well, you wake up in the morning, you take your bath, you dress up, you take a light breakfast, you go outside, you use your car or public bus, you get to work. Tuesday, you still have the same problem of getting to work. You wake up, you take your bath, you take a light breakfast, you go outside, use your car or public transport, you get to work. Wednesday, you wake up in the morning, you take your bath, you dress, and you're not doing the same thing. You're repeating the same thing. But you are doing this to solve a problem. Although you don't know you're following an algorithm, but you are actually doing that. If I tell you now, for those of us that at least let's use white rice, at least I believe everybody here suppose to be cook white rice. Now, if I tell you to make white rice now, okay, and I tell you to make it 20 times in a month, just white rice, you will discover that the process you follow in making it that 20 times is the same process. So if I now decide that, okay, you know what, I don't sabi cook white rice, I don't be cook, I want to start writing a cookbook, okay, and now list out all the instructions for making white rice. That instructions I've written down now is what we call an algorithm. A step-by-step instructions followed to solve a particular problem. I know that good, I'm very good at cooking white rice, and I know there are a lot of men out there that don't know how to cook white rice, and I'll become an influencer, white rice influencer. I released a book on how to cook white rice. I put the steps down on how to cook the rice, how to measure, how to do all of that, and boom, that book that I've written and I want to give out, we can refer to it as an algorithm. Why? Because it is a step-by-step instruction of cooking white rice. There's a problem of cooking white rice, and I just solved it by giving a step-by-step instruction to solve it. Do we get it?
Mm-hmm.
Now, if you hear somebody just somebody came up with an algorithm to solve one particular math problem, and they call him a math genius, what they are trying to tell you is that there was a problem before that was difficult to solve, but somebody came up with a step-by-step instruction on solving it, and the instruction works. For your algorithm to be a valid algorithm, you need to work. I should not write a book on how to cook white rice, and the person ended up cooking stew. So if you are writing an algorithm, it should always work. Now, we still have the same concept in programming. Whenever you are given a problem to solve, you need to first sit down on your own, draft out a step-by-step instruction on how you can solve that problem. If not, you might not be able to write the program to solve the problem, because a problem you can't solve by thinking about it. You can't solve it with code. And that is why they will tell you, as a developer, you will spend 80 to 90% of your time thinking and 10% of your time writing code. And that is the difference between a junior developer and a developer that is more expensive. I mean, that is more experienced. I think we had an intern, was it, I think 3 months ago at my office, and the guy was like, Mr. Steve, I just noticed that sometimes you just be walking around the office. Sometimes that's what I do though. Sometimes I'll leave my seat and I'll be walking around the office building. I say, no worry, you never understand. When you start taking on tasks that I'm taking on, you will know that there are problems that can't be solved sitting down. Most of the time, you are busy thinking. Because if you don't know how to solve, just imagine me that I don't know how to cook white rice. I want to write a book on how to cook white rice. Exactly. You can't provide the solution. You can't write the code if you don't know how to do the thing. So a lot of times you are always thinking. And if you would agree with me, okay, when you have a problem and you are thinking about it, it is not every solution you come up with that is perfect for solving the problem. So sometimes you might come up with more than one, more than two, more than three algorithms to solve it. Okay, Technocrat said he had to go, but he will be back soon. No problem with that. You can watch the class. So, as I was saying, it is not every solution you come up with that is perfect. Even when you come up with a solution, you need to examine the solution if it is perfect to solve the problem you want it to solve. Okay? So, as a developer, I'm telling you this now. Whenever you want to write code, or I give you an assignment, always sit down back first and think of, okay, if ask yourself, without programming, if you are to solve that problem, how would you solve it? If you know how to solve it, then you will know how to write the code for it. So let's come up with this problem we have. We want to write a program. Okay, we want to write a program. Samuel, you raise your hand. Please speak up. Or it was the one you raised earlier today.
Okay, I took it earlier. Let me know it.
All right. So if I ask you now, okay, please write a program to print even numbers from 1 to 20. Let's leave Python alone and sit back first. Without Python, how would we solve this? Let's write the algorithm to solve this problem without Python. You know, I told you algorithm is a step-by-step instruction, right? So we want to write the instruction. If I ask you, write me an algorithm to find even numbers from 1 to 20. You already know that this operation you want to perform will look like a loop, right? Because you know you want to find, you have so many numbers, up to 20 numbers, right? Okay, you know what? Before going to 20 numbers, let's break this problem down. This is another thing you can do as a developer. Whenever you have a problem that looks too complex, look at the problem well and see if you can break it down. Now, let's break this problem down. Instead of looking for an algorithm to find even numbers between 1 to 20, let's first write an algorithm to find out if a particular number is an even number. Do you agree with that? So instead of writing an algorithm to loop over, let's at least be sure that we can write an algorithm to confirm first if a number is an even number. So let's do that. So the first thing we want to do here is, let's first of all get the number. Now you can write your algorithm in any language you like. English, Hausa, Yoruba, Japanese, Spanish, as long as your algorithm is meaningful to whoever is reading it. So I'm saying get the number. Then after we get the number, what's the next likely thing we want to do? We want to confirm now if this number is an even number. How do we confirm that? Well, we already know that even numbers can be divisible by 2, right? When you divide an even number by 2, there should not be a remainder. Do we agree with that?
Mm-hmm.
If we divide an even number, okay, let's break this down a bit further again. We know that even numbers can be divisible by 1, by 2, and themselves. But if you divide an even number by 1, there is really no way to know if it's an even number, because even odd numbers can be divided by 1. You can divide 3 by 1, you can divide 5 by 1, you can divide 7 by 1. So because of that now, that approach will not work for us. So we'll cancel that approach. Okay, let's look at the approach of dividing an even number by themselves. 2 divided by 2 is 1. Okay, that makes sense. 4 divided by 2 is 4 divided by 4 is 1. That makes sense. But the same way you can divide an even number by itself, you can also divide an odd number by itself too. Do we catch that?
Mm-hmm.
Because 5 divided by 5 is still 1. So let's look at the approach of, okay, but it seems we can divide even numbers by 2. Because if you think about it, if you divide even number by 2, the remainder is 0. But if you divide odd numbers by 2, the remainder is always 1. Let's confirm that. 2 divided by 2 is 1 remainder 0. 4 divided by 2 is 2 remainder 0. 6 divided by 2 is 3 remainder 0. Did you notice the pattern there? But let's try to divide odd numbers by 2 and see if it will be the same thing. 3 divided by 2 is 1 remainder 1. 5 divided by 2 is 2 remainder 1. 7 divided by 2 is 3 remainder 1. Did you notice the difference now? When you divide an odd number by 2, there is always a remainder of 1. But when you divide an even number by 2, there is always a remainder of 0. So we can use that now as a condition to determine if that number is an even number or is an odd number. So all we need to do is divide the number that is given to us by 2. If the remainder is 0, we know it's an even number. But if the remainder is 1, we know it's an odd number. Did you catch what we just did there now?
Yeah.
Good. So the next line, we would say divide the number by 2. So don't forget, we are writing an algorithm to find out if a number is an even, if a number is even. Let's just say if a number is even. Sometimes too much English will cause problem. So what's the first step? Step 1, we get the number. Step 2, we divide the number by 2 and store the remainder. Then step 3, we want to check if the remainder is equals to 0. So we'll say if remainder is equal to 0, let's just type 0, then number is even. Did you see that? Let's test this our algorithm now if it works. Let's try to find out if the number 129 is an even number. Okay, so what's the first step of our algorithm? We should get the number, right? So what is the number here? 129. What's the second step of our algorithm? it says we should divide the number by 2. So the second step now says take 129, divide it by what? 2. If we divide 129 by 2, what will be the answer? That should be 63, right? Let's confirm. Let me bring up calculator. It should be 63 remainder 1. So 129 divided by 2. Oh, 64, not 63. 64 remainder, that should be 64 remainder 1. Because if you do 64 plus 64, you get 128. So we get 64 remainder 1. But we said we should store the remainder, right? We are not interested in the 64. We are interested in the remainder. So we set the remainder to 1. Now, our third step says if the remainder is equal to 0, then the number is even. Our remainder is 1. Is 1 equals to 0? Which means this 129 is not even. Do we agree with our program now? Now, which means looking at our algorithm, we can say yes, our algorithm works. Right? Yes, it works. Which means our algorithm now is tested and trusted. Now that we have the algorithm to check if 129 is an even number, I want to delay us a bit. Let's try to write a Python program to replicate this algorithm. For now, we are not talking about loops again for now. We'll come back to loops. So let's try to write a Python program to replicate this issue here. So what do? Well, we come down. I'm going to say, what's the first step of our algorithm? Now, we want to check if 129 is even number or odd number. The first step of our algorithm says we should do what? We should get the number, right? So we can say num equals to 129. That's the first step. The second step says divide the number by 2 and store the remainder. So we can say remainder is equal to 129 divided by what? 2, right? Wrong. This will be wrong. Don't forget that when you do 129 divided by 2, it will return 64.5. Are we together? But if you remember when we were treating operators, I introduced you to one operator that will do division and return the remainder. Who can remember that operator? When you use the operator to divide, it will divide and return the remainder for you. Who can remember that? Who can recall? Let's try. Let's try. Let me see.
Is that not conditional?
It's not really conditional. Let me see if we have those. If we go back to our basics class, where we talked about operators. Yes, operators. Let's see if we remember them. Arithmetic operators.
Okay.
Modulus operator. This is it. Modulus. That's the operator.
Okay.
You remember when we do 10 mod 3, it will return 1, right? So the modulus operator will do a division and return you the remainder, and that is perfectly what we want, because we are not interested in the division itself. We are interested in the remainder. So now, instead of using that operator sign, we'll use the modulus operator sign. So remainder is equals to 129 mod 2. Now, what's the third step of our algorithm? It says if the remainder is equal to 0, the number is even. So what we want to say is if and else in Python, we talked about this in the last class. If remainder is equal to 0, then we want to print 129 is even. Then let's put an else block there. Else print 129 is not even. If we execute this now, did you see what it says? Did you see this? It says 129 is not even. And was that not the answer we got when we ran our algorithm too? Now let's try to make this, put an even number here. I know that 20 is an even number. Let's run this. Of course, it will say 129 because we had coded it. Let's just simply print even, not even. If I run this now, you see, it says not even. Oh, we are still doing 129 here. My mistake. We are supposed to put num, not 129. Num mode 2, not 129 mode 2. You see, it says it's even. Let's put an odd number here, 21. It says not even. Did you guys see how we have miraculously written a Python program now to determine if a number is even or not even based on the algorithm we wrote? Good. Now that we could do this, let's go back to this our issue here where we want to print even numbers from 1 to 20. So we want to look at 1 to 20 and print out all the even numbers. So this is what we want to do. Since we already know the algorithm to print an even number, this is what we want to do. We want to loop over all the numbers from 1 to 20, and while we loop over every of them, we want to perform all this operation here. So let's write the algorithm to loop over even numbers. To print even numbers from 1 to 20. I got disconnected. I just got disconnected. Can you guys still hear me? I think it's my net data was supposed to expire today, and I guess that's why these people are disconnecting it. Okay, do you guys catch what we have done with this even number here when we printed a single? Maybe what did you say?
I have a question.
All right.
Here it says if remainder is equal to 0.
Yes.
Why do we have double equal to be?
This is a conditional operator. Double equals is a conditional operator.
Okay.
What is doing, this is not equal in the normal assignment. Single equal is an assignment operator. What this if statement, hopefully when you watch the last class you understand better, but what this if statement is saying is if the number is equal to 0, so we are checking if the remainder is 0, run this code, else run this code. Did you get it? So what it will do is, if you do num mode 2 will return us, num mode 2 will return us 1, because 21 divided by 2 is 10 remainder and 1. So this will return us 1. 1 will be stored in remainder. Now we are saying, is 1 equal to 0? The answer to that is no, 1 is not equal to 0. So it won't print even. It will come to the else block and print not even. Please again, go back to our last class and watch it, okay? It would explain this if statement more to you. All right?
Thank you.
All right. What's wrong with this network? You guys can hear me fine, right?
Hold on, clear.
Okay.
Yes.
All right, good. Let me see if I can. I want to do that top up before these people start telling me data is exhausted. Just give me a minute to top up, please. Okay, good. So what we want to do now is this same algorithm we have that is doing it for one number. Let's try to replicate it to do it for multiple number. So the first thing we want to do is we'll say get, so we'll say loop through all the numbers. So that will be our step 1. Loop through all the numbers. step 2, step 3, step 4. Then step 2 will be get the current number. You know, when you are looping through a number, you will be getting every time the loop runs, in each iteration you will have access to the current number, right? So if you are running a loop now, if a loop runs 1, the current number will be 1. The second time it will be 2. The second time it will be 3. So we'll say get the current number, divide the current number by 2 and store the remainder. Then if the remainder is equals to 0, then the number is even. That's just it. Now let's just quickly replicate this using Python. So we want to use a while loop for this. So where do we want to start from? We want to print even numbers from 1 to 20. So our start number, let's create a variable to store start number as 1. So we'll say while start is less than or equal to 20. Okay. Now, you know that, okay, instead of calling this start, let's call it our current number, because according to our algorithm, we called it current number. So let's say current num equals to 1. So why current num, why current num is less than or equals to 20, what do we want to do? Well, earlier we wrote the code to find out if a particular number is an even or odd number. So let's repeat that code now. So we'll say why current num is less than or equals to 20 if, you see, I'm having an if statement inside a while loop. Mr. Victor, you remember in last class we talked about nested if, right?
Yeah.
This is the same approach, but just at this time, instead of an if statement being inside another if statement, we have the if statement inside a while loop. Okay, so we'll say if current number, okay, mode, you know, that was how we found out if it's a odd number. So if current number mode 2 is equal to 0, okay, if current, or let's break it down the same way we broke it down here so that you guys don't get confused with it. So we can say remainder is equals to current number mode 2, and then we'll say if remainder, if remain, is remainder I wrote though. I just knew something.
Don't worry.
So if remainder, what's wrong with this mouse? If remainder is equals to 0, now if remainder is equals to 0, it means that this number is an even number, right? So we want to go ahead and print the current number. Perfect. Let's run this code now and see what we get. Let me drag this up, reduce this a bit, hit execute. Something is wrong, it's not running. Why are you not running? If current number is less than or equals to 20. Oh, I think it hit an infinite loop. So it hanged. Yes, it did. Who can guess why it hit an infinite loop? We did not increase the current number the same way we did in our first loop. You know, I told you have to look for a way to make it.
No, equal to num plus 1.
Exactly. So we'll say current num is equals to current num plus 1. If not, your program will hang. And that should enable it to execute now.
So that current num equals to current num plus 1 must not be an indentation. It must not be under
No. It shouldn't be under the if block. Okay? It should be under the while indentation, the while block indentation. That was why I moved it. You know, if I tab it now, it means it's inside the if block. But if I bring it out, it means it's under the Y block. And I'm doing it last because if you move this piece of code up, current norm would have been increased by 1 before your if block runs. And we want the if block to run before the current norm increases. And if you look at the console now, you will see the results there. It's actually executed this time around. They did not hang again. You see that? So it's printed 2, 4, 6, 8, 10, 12, 14, 16, and you can see that these are all the correct even numbers. Now let's run through this. Okay, let's run through this and I will explain it to you how it executes, and I will give you 10 to 15 minutes for a class work. I want us to practice today. All right. Now, Samuel, if you are not with your system, are you with your system currently? Just wave your hand if you are, because I know you are at work, so you might not be able to speak.
Yeah, no, I'm not necessarily.
Okay. If you're not with your system, if you want to practice Python
Mine is running.
You said?
It's running infinitely.
And maybe because you did not increment.
Yeah, I put that current norm is equals to current norm plus 1.
Make sure you did not put it inside the if block.
Not within the if block.
Huh?
It's not within the if block.
Okay, just be sure of that, because that would be the only reason it doesn't run.
No, it ran, but it ran infinitely.
Okay,
Stop it.
end the program. Click this end button here.
Activated it.
Now rerun it. Okay, so for Samuel, if you are not on your system, you can actually go to this website called REPL It. Although the process to use REPL It is plenty, you have to register. Just search for code Python online. You should get one of these online code where onlinepython.com. Okay, this site here. Should be able to write Python online without okay, good. So this environment now, you should be able to write Python here. See, if I come here, let's go to dark mode. Me, I like dark mode better. So if I come here now and I just print, let me do print. See the same print we have been writing. So if I come here and I say print tech, it's just that here you will not get autocomplete like you used to get in Visual Studio Code. So if I say print tech with Steven, and if you want to execute, where is the play button? Oh, I zoomed in too much, so the play button disappeared. This is the play button here. If I execute that and I scroll down just a bit, it's trying to run. You see that it ran well. Tech with Steven. Even this code we just wrote here now. No? This code, if I copy it and I paste it on that website and I execute it, you will see that it will run. Did you see it? It printed all the numbers. Did you see that? So you can visit this site. Just search, just go to www.online-python.com. You'll be able to write your Python code online. This is sometimes when I'm not with my laptop and I discover one new thing in Python and I want to practice, I come here too. There are a lot of them, a lot of websites you can practice, but this is just one of them. So let's go over this code. I want to try to explain it to you so you understand it, because I'll be giving you a classwork of writing a Python program that will print odd numbers instead of even numbers. And I want to see how you can tackle that. So how does this run? Well, when the code starts, it sets the current number to 1. the first number we want to, because the question says print odd number even numbers from 1 to 20. So the first number or current number is 1. Now we are saying why current number, which is 1, is less than 20. So if 1 is less than 20, which is true, it will enter this block. So it will tell us that, okay, it will find the remainder. The current number, which is 1 mode 2, 1 mode 2 will return us 1 mode 2 will not return anything because there is no remainder. 1 cannot even divide 2 in the first place, so 1 is totally useless to us. And if you find out, if you look at our output, you will discover that 1 was not included. Look at it, there was no 1 there, it started from 2, so it will move to 2. Is 2 less than or equals to 20? The answer is yes. 2 mode 2 is 2, it's 1 remainder 0, so there is a remainder. Then it will check, is remainder equals to 0? Of course it's equals to 0, so it will print 2. That is why we have 2 there. That is why we have 2. It come up again, it comes down, it has 1 to 2, so 2 becomes 3. Is 3 less than or equals to 20? Yes. Then it comes down. 3 mode 2 is actually 1 remainder 1. Is the remainder equals to 0? No, the remainder is equals to 1. So this if will not run. It will come down to this line and add 1 to 3. 3 becomes 4. Is 4 less than or equals to 20? Yes, it is. 20 mode 2, sorry, 4 mode 2 is 2 remainder 0. Is the remainder equals to 0? Yes, it will print 4, which is why we have 4 next. That is basically what it will keep doing until it gets to 20. By the time it adds 1 to 20, it becomes 21. Is 21 less than or equals to 20? The answer is no. So this loop will stop executing. Did you see how the program executes? If you've got a question on that, please wave your hand and ask your question. Maybe or any question? Hello, maybe are you with us? Hello, maybe are you with us? Mr. Victor, you can hear me, right? Hello, Mr. Victor. Sorry, I think I had issue with my network there. Maybe, or can you hear me? Mr. Victor, can you hear me, please? What is wrong with this network? Hello, guys, can you hear me?
Yes, sir.
All right. Did you understand the explanation I gave here? Or I was disconnected? Mr. Victor, can you hear me? Hello, Mabel, can you hear me? Okay, this network is pissing me off.
Yeah, you allowed to run it infinitely. I still don't know the reason why it was like that.
Okay.
I've deleted it several times to run it again.
Okay.
And the same is the symbol that
Can you copy your code?
down here.
Can you copy your code and send to me on WhatsApp?
Let me see if it's possible because I'm not using the same device.
Okay. Or can you copy and paste on
Oh,
the
let me. I have WhatsApp on my laptop, so let me just open it.
All right,
That's
all
no
right.
problem.
Okay, so Mabel and Mr. Samuel, I guess you understood the explanation for how this code runs.
Well, having code.
You were
Why?
you were having what?
Having error.
Okay, let me zoom in so that you guys can be sure you're writing the same. Make sure you comment every other code at the top of your code. Comment out every other thing at the
Connected
top.
everything.
Okay, good. Then let me zoom in more. So check out what I have, compare it with what you have. And if you still have an error, let me know.
I've sent you the code now.
Okay, you've sent the code. Let me check it out. I guess network is bad because I've not gotten it. Okay, I just got it.
Can you see it?
Yeah. If remainder is equal to 0, okay, print current norm 1. Okay, I'm seeing your. All right, so let's do the assessment together. We've written the code for odd number. Let's replicate for even. So we'll say, oh, the upper one was even. Sorry, this is even, and this is odd. So for odd numbers, I will paste the code back. The only difference that will be here is this: instead of stopping at 20, you stop at 50. And instead of doing current number mode 2, don't forget the explanation I gave when we were talking about algorithms. We said the difference between an odd number and an even number is that when you divide an even number by 2, the remainder will be 0. But when you divide an odd number by 2, the remainder will be 1. So you can still leave this code here as dividing it by 2. Then you will check if the remainder is equal to 1, not if it is equal to 0 like we did before. And then you increment. If we run this now, it should give us what we expect. Did you see that? If I scroll up, 1, 2, 3, and Mr. Victor, I'm thinking your own starts from 1, but if you scroll up, you should see it. Scroll up.
Okay, you might be right.
Exactly. Scroll up, because you see if I don't scroll up, it looks as if it starts from 21. But if I scroll up, you see that it actually starts from 1. So this is the solution to the assignment I expect you guys to write.
It's still at 27 that I started from.
No, it shouldn't be. It will probably be hiding. Okay, to be sure, instead of doing 1 to 50, do 1 to 10 first, so it doesn't have to print a lot.
Good. So let me just use that one to test run.
Exactly. So it doesn't have to print a lot.
Yeah, this one is different now. This one gave me 1 to 9, 1, 3, 5, 7, 9.
And the other one was giving you, hopefully it's because you could not scroll up.
I think so. Let me just assume.
All right. So that's for that.
I think I got the code right.
Yeah, that's for that. So with that being said, let's look at the for loop now. Let's look at the for loop. For loop. Now, the for loop, unlike the while loop, we majorly use the for loop when we want to iterate over a collection. So if you have a collection like a list of numbers, you have a list of items in an array or a list or a set. I know we've not talked about set and all of those things, but hopefully we'll talk about list before the end of today's class. Later we'll talk about dictionary, tuples, and co. So what I mean is this: once you have a list, a list in Python or a collection in Python is a data type that can hold more than one item inside of it. You know how we can create a variable num and store only 3 inside of it? Are we together? Mabel, are you with us?
Yes.
All right. You know how we can just create a variable and store 3 inside of it? We can come and create a variable called nums and store more than 3 items inside of it. And this is what we do. I can come and say, did you notice I'm putting comma after everything?
Yeah.
Now, this kind of thing is what we call a list. Now, once you have a list in Python or a collection and you want to loop over, maybe we want to print out all the items in that list. Okay, we want to print out all the items in this list now. Okay, this is where a for loop will come to work. Unlike a while loop, you don't have to tell a for loop when to start, how to start, and how to end. You know, in while loop, we are the one putting condition and increment there. For a for loop, you don't have to do that because the for loop is working on a collection. Once the collection ends, you know it will end. So if you use a for loop, let me reduce this number to run through this thing now, to run through this now. It will start from 4, 65, 6. Once you see that there is no number after that one, it will stop by itself. Do we catch that? So that is what a for loop is basically used for. To show an example of that, let's try to print out the same code we have been writing here since. Let's try to print out numbers from 1 to 10 using the for loop now. Now, this is a secret in Python. When you are in Python, you can get a range of numbers if you are working in Python. Like if I want Python to generate a list of numbers for me, I can use this function called range. And you see, the moment I bring it up, you see this pop-up that shows. It says I can put a start. Okay, I can put a start and a stop. Basically, we can tell this range to generate numbers from 0 to, did you see I did 0, 10. Let's print this out now. Let's print this out and see what it gives us. If I run it, oops, let me rerun that. Did you? Oh, it just printed range 0, 10. What's wrong with it? Oh, it's actually a collection, so we have to loop over it. If you do like this, it will still give you the thing back. We have to loop over it. Let's try to loop over it and see. So let's say nums equals to range 0, 10. Then let's loop over this using the for loop. Like I told you, the for loop works like the while loop. The only difference is you don't need to tell it when to stop, when to end. It knows what to do. Now let's see it in action. I can say for num in nums. What this English here means is that for every number, this is a variable. You can call this thing anything you like. I just call it num. I can call it x. Okay. Now I'm telling Python for every number in this collection called numbers. Don't forget that I told you that this range 0, 10 will generate a range of numbers between 0 and 10 for us, which means we have a collection of numbers. Now I'm telling Python that for every number in numbers, what do we want to do? I want to print the number. So let's say print num. If we execute this, let's see what we get. Did you see? We get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but we are not getting 10. That's because when you are printing, when you are doing range, okay, you put the start number 0, where we get 0 here. But this last number is always non-inclusive. I don't know if it's a bug, but that's just how Python works. Basically, to fix this, what you need to do is this. If you want to generate numbers between 1 to 10, say 1 to 11. If you want to generate number between 1 to 15, say 1 to 16, always add 1 to the last number. Is that node, is that
That's one.
taking? Maybe, or do you flow with that? Maybe,
Let me see your code.
okay. You said what?
I didn't really get it.
What I'm saying is that when you use range of 0 to 10, Python will end up generating numbers from 0 to 9 for you. 10, this last number here is always non-inclusive. Basically, the way to fix that is, if you want to stop in 10, instead of just saying 10, say 11. Maybe, are you with me now?
Yes.
So if I want to print numbers from 1 to 50, I'll say 1 comma. What do I put? If I put 50 here, maybe, do you think it will print 1 to 50 for me?
It will print 1 to 49.
Exactly. So if you want 50 to be included, you put 1 there. Good. So let's reduce this back to 11. So now I'm telling Python, for numbers in this collection of norms, print out the number for me. If I run this, did you see what it gives us? So it gives us, let me end, rerun. See that 1, 2, 3, 4, 5, 6, 7, up to 10 now. You get it. Now, this range at the back end, what is it doing? Simply just returning norms equals to, it will return a list of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why if I comment out this line now, you see I've commented out this line. If I still run this code, you will see that it will still run fine. Do you see? We still get our 1 to 10. It still works fine. That is basically how what the range operator is doing at the back. Hello guys, are you with me? I think I disconnected again. That is how you can use the range, this range number here, okay, to generate, because at the back behind the scene, this range 1,11, this is what it's doing at the back. It's just generating numbers from the start number to the end number. Okay, so if you want 1 to 50, you do 51. But why this approach, mostly if you are dealing with number, is better than this approach is that if you use this approach, you have to type it with your hand. So if you need 1 to 200, you have to type 1, 2, 3, 4 till 200. But if you use this range, you are good to go. Do we catch that?
Yep.
All right. So that's the for loop. So basically, when you want to use the for loop, you use the for loop to iterate. The common things we use for loop to iterate over in Python is list, dictionaries, tuples, sets, and a range of numbers that we just looked at. Okay, and a range of numbers. So let's quickly look at list. Let's quickly look at list. This is the only extra topic we'll look at today before we call it a day. But we might not be able to finish it because there are a lot of list methods. But let's start. So I guess that ends the talk on loops for now. Although don't forget that as the class progresses, most of these things we are learning and we are thinking we are leaving, we are not leaving them. We'll be using them. In the next class now, we will take what we have learned from this class and improve our guessing game. So instead of having one question, we want to have a list of questions. But let's look at list first. So I'll create a new project. I'll create a new project called list.py. Good. So in list.py, what do I want to do? Let me rename all these things. Let's rename this. No, let's leave the naming. I don't want to stress myself. So what is a list in Python? Not to speak too much English or grammar. A list is just a collection of items stored with one variable name. You know, the way you will say name, or I will say fruit equals to mango, right? This is just one variable holding one value, right? Are we together?
Yeah.
Maybe are you with us?
Yes.
Good. This is just one variable holding one value. If I want to have one variable holding multiple value, which we call a list, okay, we could have called this collection, but Python calls it list. So I will simply say fruit. Now I can call it fruit, nobody will beat me for that, but it makes common sense that when you are storing more than one thing in a variable, you pluralize the name of the variable so that it's easy for people to tell, right? So instead of saying fruit, I'll say fruits equal to, then open and close curly bracelet, that mustache symbol. Okay, you open it in Python self, it will open, and if you open it will close it for you. So inside here now I can throw in fruit there, mango, comma, pear, comma, apple, comma, orange. Now you notice that everything is separated with a comma. Everything is separated with a comma, because although they are inside the same collection, they are individual items. And of course, according to what we learned in the last class, you learned that we can print all the items in this list, right, by looping over them. Using which loop will we use? For loop or while loop? Mabel? If you want to loop over a collection like this list in Python, which loop will you use? For loop or while loop?
While.
While loop. Mr. Victor, which loop will we use here?
For loop.
For loop. We just finished discussing it, Mabel. I told you when you have a collection or a list or a range of numbers, you use the for loop. That was what we did here when we had numbers equal to this. The only time you use a while loop mostly is when you are not dealing with a collection or a range. You want to be incrementing yourself. That's when you use a while loop. But whenever you have a list, a dictionary, a set, a tuple, or a range of number, you use for loop. How do you know a list in Python? Once you see opening curly brace and closing curly brace, and you see that every item inside of it is separated with a comma, that there is a list. So to print out all the items in a list, we use a for loop. So I can say for x in fruit, x here is referring to every item in the fruit. So I'm saying for every item in this fruit, I want to print the item, so print s. If I run this now, do you see this? We get our mango, pear, orange, and so on and so forth. Did you see that now? Okay, good. Now, what other thing can we do with a list? Let's see what we can do with a list. Well, let's quickly look at, we have looked at how to create a list. Let's look at how to access items in a list. So to create a list, you just give the variable name equal to open curly bracelet, close the curly bracelet, then you put whatever you want to put inside a list. Now, a list can hold any type of data type. It can hold a number, it can hold a string, it can hold a boolean, it can even hold mixture of everything. For example, I can come here now and do comma 40, comma 60 something, then comma true. You know true is boolean, right? Maybe, are you with us?
Yes.
Good. If I execute this now, let's print all of them out. You will see that we will still work fine. See that it will still print everything out fine. Okay, so a list can contain any number of items. Now, if you want to print out all the items in a list, you use a for loop. But if for some reason you want to print out just one item in a list, you use the index position. You guys remember when we taught strings, right? And I told you that if each character in the string has an index position, do you remember that? For example, if we have name equals to Mabel now, okay? If I want to print out M from this name, what do I do if you remember? The first letter, if I want to grab the first letter from Mabel, what do? I can simply say name square bracket, put the index position of M. What is the index position of M? You guys have forgotten this.
1.
No, index position starts from 0. Do you remember this thing now? Mr. Victor?
Yeah, my brother.
You remember we talked about this, right? Index position, when you have a string, each character in the string has an index position. M is 0, A is 1, so on and so forth. That I was telling you that index position is different from the length. When you talk about length, the length is always 1 more than the highest index position. Do we remember that we were doing some calculation that day? All right, please, if you don't, I advise you go back to the previous classes and watch them again. So to get M out of this, just put the index position of M, which is 0. If I print first letter now, you will see that it will print M for us. Did you see that? If I want A, put the index position of A, which is 1. If I run that, it prints it 2. This same thing we are doing to a string, we can do it to a list too. That is because under the hood, a string is actually a list. It's a collection of characters joined together. So if I want to get mango, Mabel, can you tell me what I will do now that will print out mango for me, following this example we did here? Hello, Mabel. Are you still with us at all? I don't think she's with us.
I'm here.
Okay.
Sorry, I need to get something. So,
if I want to print
if you
out
want to print
mango from this fruit now, following the same approach I used to print M from this name, look at what I did. To print M, I called the name of the variable, open square bracket. Okay, it was A I printed. Open square bracket, then I put the index position of A, and then I close the bracket. Now I am telling you that under the hood, a string is a list. That's why we could do this. And whatever, if we can do this for a string, it means we can do it for a list too. So if I want to print mango here now, what do? I can simply come down and say print. Let's first of all collect the fruit. So we'll say fruit is equal to fruits, then square bracket, which index position, Mabel? What's the index position of mango?
1.
What's the index position?
0.
0 there. And if I come now and I print fruit, let's delete this. We don't need this, or let's just comment it. If I run this now, oops, we got an error. What's the error saying? Set object is not. I think I'm making a mistake. Let me be sure I'm not making a mistake. Oops, my bad. I've made a mistake. To make a list, you don't use, it's not curly bracelet, it is square bracket. Sorry about that. Curly bracelet is set. You see that immediately I did that, it gave me an error. Okay, that's an error on my part. It is not curly bracelet. It is square bracket, square bracket. Okay, let's keep that in mind. All right. Are we together? Hello, guys. Mr. Victor, are you with us?
Yes,
Yeah.
sir.
You're with us,
Yeah,
right?
yeah. I mean,
So it's not curly
Yeah, sure.
bracelet, it's a square bracket. You see, immediately I did that, it gave me an error. So let's rerun this again, and you should see we should get mango. Do you see? We get mango. If I come back here now, I want to print pear. What do I do? What's the index position of pear?
1.
Exactly, put 1. If I run that, you see it gives me pear. So that is how you can access items in a list. You can also change the item in a list using this approach. For example, if I want to change pear to maybe carrots now, what do I do? Well, it's simple. I can simply, let's get rid of, let me comment that line. I can simply say fruits, then supply the index position you want to change. What's the index position of pear? 1, right? I'll say fruit at index position 1 should be set equal to carrots. If I save this now and I run this, you will notice the new list we got. Pear, this is the position of pear has been replaced with carrots now. Did you see that?
Mhm.
So this is how you change the value of, this is how you change the value, or this, let's just say this is how you change an item in a list. And then this one up here that we did is how you access an item in a list. So to access, just say fruit, then you put the index position. It will return the fruit for you. To change, call the collection, the list I mean, put the index position, set it equal to the new thing you want. That will do it for you. Okay? If you've got questions, please ask.
Sorry, why for this one, why did we use square bracket?
Square brackets.
Mm-hmm.
I told you guys that earlier. I made a mistake using curly bracelet. Curly bracelet is for top sets. And we'll talk about that in the next.
I'm really dozing off, so I didn't get that part.
Okay. And we would fix that. We'll talk about set in the next class. But for a list, it is square bracket. Square brackets for a list. Okay?
Yeah, that's fine. So
Alright.
let me see your code. I beg of you.
No problem. That's the last thing we'd even learn today. So you can go back to bed.
I need to go sleep.
And maybe send me a message later so that we'll go through that your error. But make sure you log into your system, because if you are not using your system, we can't really debug. So
Why did you put number in the range for fruits?
where? This one.
Yeah, fruit is square bracket, mango, pear, apple, orange.
Yeah, I just added number there to explain. Maybe you did not catch that. To explain to you that a list can contain any data type at all.
Both string and number.
It can mix everything. A list self can contain a list.
Okay, that's fine.
That case, we now call it a two-dimensional list. We'll talk about it, don't worry. But I can delete that for now. I just explained.
No, never mind. I did stuff like I did something like this on Thursday, but I was confused.
Okay.
I was just
All right.
so that we can.
So a list can contain anything at all. It can contain a list of numbers, string, booleans, even a list of lists.
That's fine.
All right. Okay. Let me see if there's one quick thing we can quickly chip in before we call it a day. Okay. Let's quickly look at one method in a list. This method is very common. Oops, sorry about that. This method is very common when working with a list, and that is the method we call the append method. Basically, what this method does is it add a new item to the list. So we call it append. When you hear append, it means add. So if I come down here now, before I print the list, let me say print, no, not print, sorry, fruits dot append. Let me add a new fruit there. Let me say salad. If I run this code now, you will notice that salad was added to the end of the list, to the very end of the list. So that's what append does, adds a new item to the list. Now, while we are coding, just like I've always been doing, I'll drop a link to a material you can go read up on list, so you can at least use it to practice before the next class. But at least with what you have learned so far, it should be easy for you to understand those materials. Maybe, I hope you're still with us. Sorry, Mr. Victor. It happens. You just, some of the sacrifices you have to. You said what? Maybe.
Yeah.
You said what? You said something.
I thought it's a bit of gonna sleep. Very tired.
Okay,
Maybe
maybe.
let me add another question. Maybe I was
Okay.
I was not with you guys, during the course of explaining some stuff. He said fruit equals square bracket, orange, pear, apple, sorry, mango, pear, apple, orange.
Yeah.
If I want to run it to show, the set of fruit, what should I do?
You to print all the fruit
Yeah, just print all the fruit.
individually.
Yeah. No, I want the 4 fruits to show like that.
Without the numbers.
Just put 3 fruits.
Yes, you can just do print fruit. It will print. Look at this. If I say print fruit, see it will print all of everything inside the list for you.
Okay.
But if you want to print them individually, that's when you will use the for loop.
Okay.
That's when you will use the for loop.
Okay, that's fine.
All right. So what I will do, if you are in the chat now, I will have just copied this code for you, but you are not there. Anyways, I've pasted it there for any of you that would want to copy it. So that is that for the intro to list. In the next class, we'll continue with list. We'll move to dictionaries, tuples, and sets. And hopefully, if we finish that, we'll now come back to that our project and come and improve it, make it a bit more interactive. Instead of having one question, we can have a list of questions there.
I can see the error.
All right. Let me just go ahead and end the recording so it won't be unnecessarily long.